Hello everyone, it's Peter. I welcome you back. So in this class, I want to finish up with the Java OP concept. We still leave some important topics not covered. One is static and non-static, then is FJ class and interface, then is generics and reflection and introspection. Okay. Now let's start from static and non-static. So simply saying, I mentioned this before, like static can be method or field. So method or field can only call static. Non-static method or field can call both static and non-static. This is also the method and field. Okay. Why this happens? So I want to use the example to show the life cycle of object of a class and object that is generated or loaded to the stack. We know every class when you run a class, it will first load this class to the stack, and this is mentioned in our garbage collection. Right? So in this one, right, static contains class level data and code. Code is the dot class, and the data like static fields. So there's a order of which one is first, which one is second. Now I want to use an example to show this. Now, new, let's say a class. Say give a like int wrapper. This wrapper contains some int value. Int wrapper. I just give a name. Okay. So here inside I give a static int value 1. Okay. Then I give int value 2. Give int value 2. Okay. And then source generate get and setters. I can get for both value 1 and value 2. So here you can see get and setters. So the static, and this is non-static. This is non-static. So if you want to call this value 1, by default, it will use static call static. You cannot, if you remove this static, there will be compile error. If you remove this static, it still work like this. It still work because this non-static can call static. And also, if you remove this static, it also works. So you even don't need this one. You just the value 1 equals to you need to have to identify wrapper dot value 1, or you can give another name and input. I just change this method, then I can use value 1 equals to input. I intensively using non-static method to call the value 1 because value 1 is a static. Now next I use static method initialize init value 1. So value 1 equals to 10. I use static method to init value 1. So here I run this as init value 1. Okay. Init value 1. Oh, sorry. This is int. Okay, I just return 10. I give initial value, and I also give initial value for value 2. And here I print out something. Initialize value 1. So then I use a constructor public int wrapper. I use a constructor, and I give a value of value 2 equals to 20. Okay. Then I print out create an object of int wrapper. So we will find out what's the order of those things. And then I also want to add a static block. This is static block. Static can apply to field, apply to method, and apply to just a block. So I print out print loading class int wrapper. Okay. Now let's move to the test class. New class int wrapper class. That's test. Now our first test is to watch the life cycle of the class loading and the object creation. Okay. Test class loading. So now int wrapper wp equals to new int wrapper. Okay. And then at this time I assertion.assert equals 10. wp.get value 1. Okay. And the value 2 has no value. I didn't set any value yet. Like this one. Oh, value 2 is 20. Okay, I already set this one. Then this is 20. Get the value 2. No. Let's run this one. So you can see the order. Okay. Now let's see this. So when we load int wrapper, before we create a new, so this new is the latter part. So when we new an int wrapper, we need to load the class first. When we load this class, you see, it first initializes the static fields. This is value 1 equals to initial value 1 here, initialize value 1. And then I run the static block, loading class init wrapper. And after that, I will create we'll call the constructor to create this object. So this is create an object of int wrapper. So if I change the order, cut. If I do this, what happens? Will the two line changed? So it's changed, right? Loading class, then initialize value 1. So it means that they'll follow this order. Okay. So first, it will initialize all the static fields or run the static block based on the order of your definition. Then after that, you start to create the object. Okay. Now, I just want to move back. So you can test by yourself. Now, I need to do something more. So now I create another one, wrapper wp2 equals to new int wrapper. This time, I want to this time wp2. So I create another object. Okay. Now this one I can make a copy. This is w2. They are the same, right? I want to run it. So you can see this static block is only run once once and only once. This is very important. All the static fields will be running once and only once. To understand this concept will be very helpful for us to understand the future design pattern like a singleton. Right? So this is very important. So we create two objects, but the class level field and the block will be running only once. Okay. So here, static fields or block will be running only once. Okay, only once when the class is loaded. So this is very, very important to understand this static. So we say all the static block or static fields, they are at a class level. We know static is class level. Now, next we want to test something for the class level. Okay. Now, for WP2, I set value 2, value 1. Value 1 is static, value 2 is non-static. Value 1, I go to 100. Set the value 2 to be 200. Now, the value 1 is static, means this is class level. Value 1 is at class level. Value 2 is at object level. So what's the difference about the class level and the object level? So it means if I change value 1 to 100, and it also in fact WP, the first WP. So then I will get this to also 100. Of course, WP2 is 100, this one. But for value 2, WP's value 2 is not changed, it's still 20. But the WP2's value 2 is going to be 200. Be careful for this. Let's run it. Yeah. We create two objects. So value 1 is a static field. It means it is a common or shared field across all the objects. So it's shared by WP and WP2. Or even you create more objects, they are the same. So if WP2 changes its value, and WP also can see the change, is 100. But for non-static fields like value 2, WP2 change value 2 is only for WP2. It doesn't affect the WP. So WP is still 20, but WP2 is 200 is changed. Be careful for that. Hopefully I use this example to show what is static, what is non-static. I give a summary here. Is static, is a class level, is shared by all objects of the class. It's only one copy. Again, static is class level is only one copy. And non-static is a copy for each object. Each object has its own copy. They're totally independent. So this is about the static and the non-static. Okay. Now next is about reflection and introspection. So what is reflection? The Java provides a way to get inside of the object of all the fields, even you are at a private level. This is reflection is during the runtime, it can dynamically check what's inside an object through reflection. Now, here I want to use an example about the reflection. Let's test it. Okay. Class reflection test. We say that string is immutable, right? String is immutable. We always know string is immutable. But under the attack of reflection, I can really change a string. I can mutate a string. Okay. Now, let me write the method private void mutate. Mutate, and I string starting from the source, string from the destination. I will mutate mutate a source string to a destination string. Okay. Now, how to do that? Here I can use again. I will introduce another method. We already talked about the clone equals and finalize hash code, and this is for one string, two string. Then another one is get class. Get class. Get class is to get a class of class. So let me do a simple test. Okay. Let's say test mutate. Before I write any method inside, let's use the get class. So I have a string str equal to new string abc. This is on the heap. I don't want to use the string on the in the string pool. So I can get str.get class and I assertions the same assert same. It's the same thing about get class and string.class. Okay. Get class will return class. Class is also a class. It's let me write this. This is a little bit tricky. It's called class. Class. It uses the generic type. Okay. So the capital C class is a class defined in Java class. So if you write sorry, here you click this one, open new link. This is a class, right? With the generic type. Generic type I will talk about later. Now, here you can see get class will return the class of this class. Why we have this one? Because we need to know exactly what class it belongs to. It may have a casting. You know, there could be a subclass, could be a parent class. Okay. So to understand this get class, I give an example for this one. Suppose I have class A, I have class B extends A. That's what the example we have now. Now A equals to new B. Okay. So this is upcasting. So what is class? System dot print class of A is what? Is A dot get class. Okay. A dot class, you can also get a name. So give a more detailed name. Otherwise, you can also get the class. You can run it. Oh, I missed the parentheses. Yeah, it's B, right? It's not A. The reference is A. So this class can exactly find the exact class of this object. So this object can be go upcasting or downcasting or anyway, because in a class hierarchy, it can go upper or lower. But get class will find out the exact class it belongs to. If I say B equals to new A, and if I want class of B, then I say B dot get class, then it should be A. Class of A is class B, and the class of B is class A. Right? So there's no casting, it's just new A. So then you understand this, and then you can add let me print out system dot print A dot class plus B dot class. Okay, let's just say A dot class and B dot class. They are the same. See, class A, class B. See, it's like this. Okay. A dot class and B dot class. So it means this class, if you already know it belongs to A, then A dot get class will be exactly equal to A dot class. Right. So that's what I want to say. So in this way, I can use the source dot get class or or I simply say because it's a string, just use string.class. String.class. In this class, I have a method called get declared fields. So let me use a for loop. Field. Get declared fields. So this is a new for loop. I just want to find out this is a field with reflect this one. Let me check out what's the field of the char array. We know inside the string, actually string is a wrapper of the character array. Okay, I just print out those fields. Okay. Now I just mutate. This method is not finished yet. Just I want to run the mutate method. I say ABC DEF. Okay. Just run mutate. I want to see. So there's a private char string value. You see, this private char string just along the string dot value. Okay, there's int, there's string dot value, there's a hash. So the field name is value. So I can get let's say char value equal to string dot class dot get declared. Get declared is get all the fields, including the private or non-private. Declared field with the name value. So this will return what? Convert field to char. So this is a field. Yeah, let's first with this field. Now I want to get destination. So now my char destination array is equal to dest dot to char array. Okay, this is array. Then there's an exception. Okay, it will throw no such field exception. So I just throw exception. Simply I throw exception to avoid the compile error. So then I use field dot set object. Object is source. Then I change to this destination is a destination array. This throws. Then that's it. Okay. Now here in the text, I also throw the exception. Now this is string. Now my destination is new string. I change it to def. Okay. Now let's say let me mutate str to this is test. Okay. Maybe I can give a long name. I give a meaningful name. This is I change from Alice to Jason. Okay, I just changed the two name. Now let's print out the string str is equal to plus str. Let's see what happens here. Oh, you can see they cannot be accessed a member of the private finally because it's a private, right? So I need to add one more thing. Is a field dot set accessible. I set it accessible equal to true. Then we know this string, new string Alice, this is immutable, right? It's always should be Alice, but now it's changed. See, it's Jason. So I even can use assertions dot assert equals test with string, right? So I don't have to print out. See, so it's really changed. So if you want, I just print out the string is changed from Alice to Jason, and that's it. So I can really change it. This is called reflection. So reflection is usually why we use reflection. So reflection actually is like a hacker. It destroyed the private field. It can get access to the private field and can change it. Even if it's a private field, it can change it. It can change from immutable to mutable. So this is just give you an example. So sometimes for debugging purpose, we need to know what happens inside a private field. But we use reflection to get it. Maybe we don't want to change it, but this is very useful to find out what's inside. And a very good application of the reflection is introspection. Introspection is focusing on data. So some data, I have an object, I have lots of field. I want to copy from one object to another object. The two objects are different type, but some fields are the same. I want to copy those fields. What can I do? Okay, now here I introduced the which is called the bin util. This one. Okay, that's bin utils is an API for introspection. You can see there. I need to add this common bin util here. Okay, I just copy it. I add to my palm. Let's play. So I can remove this one. This is from Apache. So it's bin utils. Oh, I think the palm is in the file system. Is in the file system? No. Okay, I just change it. Okay, now okay, now let's make a test of the bin util. We can new class introspection test. Actually, we use bin util. Use bin utils to do introspection. Okay. Public test copy. Okay, now let's do this. I want to copy between two different objects. Okay. The first one, let's say employee has ID, name, and salary, and the immutable person has ID and name. Can I copy the two objects? I think so. Employee emp equals to sorry. Immutable person, because there's no setter. I copy from the immutable person to immutable person. This is a person equal to new immutable person with ID is 1 with Bob. Okay, then employee equal to new employee, just an empty employee. Now I use bin utils dot. There's a copy properties. Copy property destination is emp, and the source is person. We know there's an exception, right? So exception. So I simply throws exception. So you know, these are two different objects. If I want to copy from immutable person to employee EMP, immutable person may have lots of fields, and EMP may have lots of fields. So what I do is the correct way is emp.setID, and then person.getID, right? And emp.setName, person.getName, right? So this is the correct way, and one by one. So if I have like 20 fields, 30 fields, then I have to do one by one. But with BinUtil, you don't have to worry about all the fields. It will automatically copy the field with the same name together. Okay. Now I can use assertion.assert equals this is one emp.getID. Assertion.assert equals to Bob emp.getName. And the salary, there's no way because there's no field for salary. So assertions assert. Let's see. Just copy. The salary is 0 because there's just a default value. Let's see if that works. See, it works. So I'd better use the copy properties. Use this method. BinUtil has some other methods. If you want, you can take API. But this is introspection. So from here, person and EMP, they may have some similar fields and they may have some different fields, but they are belonging to totally different classes. There's no relation, there's no parent or sub. But I just want to copy from one object to another object. So instead of doing get and setters, I just use the BinUtil copy properties. They will copy all of them together. They will skip the non-matching field. Okay. So these BinUtils will be very helpful for our future project because we have lots of similar classes, entities, models. They want to go each other to do the copy for each other. We don't have to manually get the fields and copy those things one by one. We can use BinUtils to save time. Okay, this is about the reflection and the introspection. And I think the last one is the generics. And the abstract class and interface, they are more about the concept. Abstract class basically is a class. Abstract class is like a concrete, the concrete class is a normal class, except it cannot be instantiated directly, cannot be nulled or nulled directly. Okay. And the interface is purely abstract. All methods are abstract. I know in Java 8 or later version, it can have some default method with default definition. I don't want to discuss that part. So abstract class interface we will use a lot in our future project. So I just give a basic concept. You can use abstract class like a normal class, but except you cannot null it directly. And the interface, you need to have the subclass to implement this interface, like clonable. Like clonable, you need to implement the interface. And for more of the abstract class interface, so after you learn a lot, and after you do the project, you will learn more about that. Okay. And for generics, I will focus on generics for the next session with the collection API, because collection API all use generics, and at that time I will cover about generics. Up to now, I will cover all the Java OOP concept. That's all. Thank you very much.